Hello, I'm Mike Elsmore. I'm developer advocate at Logz.io, and today I'm here to talk to you about keeping inside of your containers and your infrastructure. So the problem case is with all of these containers we're producing, and that is hundreds of thousands of them. We have them in the wild on all sorts of different infrastructure in different places, and we have little to no idea what's going on normally with them. You can get logs and you can get information, but what you do with this? So you can have all these things going on in the background and not have a clear understanding of your entire architecture and infrastructure to know what's going on. So possible solution is using open source tools to provide you some of the observability onto the inside of the application. Now, observability is a principle made up of three pillars. That is event logs, systems metrics, and tracing. Now, I'll go through each one of these components in a moment. Now, a lot of you may be thinking right now, I don't need this. Your infrastructure's not that big, or you don't have that many components out there in the wild, or you don't think that it's something you need to worry about. You have a self-healing system, things gracefully restart, data is always written to disk on crash. So knowing where and why the problems are happening isn't necessarily an immediate concern. However, as everybody is aware, problems are inevitable. Your infrastructure will crash, VMs may die, operating system updates may not take place and may conflict with code updates that do take place. There's a million and one things in software that mean your system can go down. Which means when you're thinking about all these hundreds of thousands of containers that are in the wild, you don't think it's going to be easy. If you take, for example, Netflix's architecture, they have that huge graph of all the individual microservices, not the individual containers, just the services themselves interacting with each other. How do they know where the information is coming from, going to, where the crash happens, where there's a bottleneck, where anything that isn't completely optimal happening, where it's happening. So we'll go through the three pillars now and see if we can build a better understanding, have a look into what our containers are doing, and probably what our infrastructure that those containers are doing as well. So first up, we have the event logs. Now, what are they in reality? They are immutable data points. They're data points made up of discrete event information. So that could be something you've put out to the console or something that's gone out to STD, log, error, etc. And the timestamp associated with it. So these could be your load balancers. So when every request is producing a log item to represent that request, usually indicative it has the method, the host, the path, etc., all in a single string with a timestamp to identify when that request was made. And it usually comes in the format of either a plain text string, usually single line or multi-line. It can be structured data, so a lot of it can be in JSON format, being the most common, or binary. Think of these as protobuf or bin logs. These are all sorts of things. We can also stream the information. So you can stream log data through to an aggregation tool. So what are you used for? Now, this is something that every developer, sysadmin, or somebody who's messed around with a computer in production is aware of. It's used for debugging and auditing and seeing what's going on. So these logs can be used to work out where the problem is, what the problem is, and give you a little bit of indication of where in the application it is so that you can go and fix it. Now, this is important when you have systems at scale that you have all these aggregated into one place. Now, what are the best open source tools for this? Well, humble opinion, the ELK stack. The ELK stack, if you haven't heard of it, is made of Elasticsearch, Logstash, and Kibana. Elasticsearch is the storage engine where you feed the logs into. Logstash is the data processing pipeline, the way you manipulate the data to make it understandable, and where you can build out the dashboards and information you want. And Kibana is a visualization discovery tool which allows you to work out where and what the problem is. You can also use beats. Beats are the data shippers. These send information into Elasticsearch rather than having to put it through Logstash for you to then consume and use. And for logs, you're very much looking at FileBeat. This one is a protocol that will read the logs you provide it and ship them over for you. Why is this easy mode? Well, to be brutally honest, it's the easiest one to generate. Pretty much every application, programming language, appliance produces logs in some format. All you need to do is connect to it something that can ship those logs over to somewhere else. Now, in a lot of situations, the platforms you run this on or the tools you're using will provide you ways of doing this. For example, if you are like I am, a JavaScript programmer, you will find libraries like Winston or Bunyan, which have protocols designed for shipping over to HTTP or even streaming via UDP, etc. So this allows you to then take everything from your program and send it over to a single point to be aggregated. So when you have 100, 1,000, 10,000 identical containers, you can see what all the information is that's going on. Next up, pillar 2, system metrics, intermediate mode. Now, what are system metrics? They're immutable numeric representations of data. So these are singular quantifiable things that you can do. Things like CPU, disk I/O, memory percentage usages. They normally consist of their name or label, or label, the specific data point, so the integer, the percentage, etc., and their unique timestamp. These can be defined values, so a lot of systems have predefined ones that they all produce. So pretty much every computer on the planet will allow you to find via some means its CPU, memory usage, disk I/O, network traffic, etc. And you can gather those and send it over. So there are a lot of predefined patterns for this. Or they can be custom metrics. For example, number of users on at one point. That is a quantifiable metric of information you can send over. Number of orders in your queue if you're running a e-commerce platform. These are things that you can then put into your metrics tool and use them as additional flags and behaviors to see what the health of your system is like at this time. So what are they used for? Well, reviewing as a time series data set, see the overall health of your system or the components within your system. By reviewing these quantifiable pieces of information over a period of time, you can see trends or spikes or problems. Now, this is information that has to actively be reported. It is also a problem if nothing is being reported. So if your container doesn't report anything for a couple of hours, that is a metric you can track to go, there's something wrong. Are those components down? Are they being fed the information from a component that interacts with it? This allows you to see what your overall health of your application is. And what are the best tools for this? Well, humble opinion, Grafana, and Prometheus. I am going to concentrate on Grafana as it's the one I am most aware of and have used the most. But Prometheus and Grafana give you the same, give you similar functionality. Why is this intermediate mode? Well, there are plenty of means of capturing metrics. With custom metric being able to be sent over, metric beat collecting them off your device. But this also makes it hard because depending on your application and what your workloads are, etc., some of these metrics can be information overload or completely pointless, or you just don't have access to them in the ecosystem you're running. For example, in functions as a service, you don't necessarily have access to things like the disk I/O or the memory usage or the network. So those basic ones that you would use if you were running the VM yourself, you don't have access to, so you can't provide those. They give you alternatives like length of execution, data objects being sent through, the size of those objects. So this isn't a one shape fits all. This is highly tailored to what your workloads and application is going to be doing. Next up is a third. Now, my opinion, this is hard mode. A lot of people may disagree with me, but to me, tracing is hard. So, what is tracing? Tracing is the end to end flow of your application, so where data is being passed from A to B. This usually consists of traces and spans. A single trace will be the single path the information takes. If it goes from the single top layer application into another layer and another layer and another layer and another layer, that will be a single trace. And each of those components will then be made of spans. So layer A, layer B, layer C, the way the information is processed through those will be individual spans. And as with things like this, tracing was designed for large distributed systems, so they're best used in microservices. What can it be used? Our other systems designs. It doesn't really work brilliantly in monolithic applications purely because it is harder to break up the individual components and where they interact. So, what are you used for? Reviewing the overall flow of your system. So you can see where information is going, or even if it is going there. For example, you may have components in the middle breaking down. So, as before, when I said with the metrics, where they may not reporting anything, that is a bad sign. With tracing, you can see where in that flow the break is happening, which would then mean you can review your logs and see why that's happening. Be that the data that's coming in means when it comes to a fork and where it goes, you can see that, oh, we just aren't receiving any information that is telling it to take this path. Or you can see that there's a break in this one microservice at this one point, stopping anything happening below it. You can also check for bottlenecks, so being able to see where certain components in your system are just churning away and taking up seconds rather than thousands of microseconds and allowing the data to cleanly pass. And what are the open source tools that work for this? Well, my favorite, Jaeger, which is a project built out of Uber and is now growing and is becoming huge within the space. There's also Zipkin, which has similar functionality as Jaeger. So why is this hard mode? Well, it has to be baked into your application. You actually have to include the agents on the devices, collectors, etc. And then you have to actually program into your application the points at which it passes the information out for the spans so that it can actually build these traces and give this information out. Now, all of these actually use or can use, well, use and can use Elasticsearch under the hood. as the data layer to store our information. So the Elk stack obviously uses Elasticsearch as its data layer, but Grafana and Jaeger can use Elasticsearch as its data layer. So that's where this is the thing that glues all these together for me, anyway. So, demo time. Let's go into our Logz.io account. It should be completely void of information right now, which it is, thank God. And over here, we have just a sample application doing absolutely nothing in the universe, and it's producing no logs or metrics or anything. So this is currently a black box. This black box is currently sat on a Unix environment somewhere, and it's reporting. Now, we could configure FileBeat into the Docker container that is part of that Docker Compose setup, and then have that report the information. Or we can set FileBeat up on the host machine and have that read off the logs from the Dockertail command. But there's a simpler option. We can just load in this, and this is the Docker collector that we at Logz.io have got. So this, if I grab it, is simply a Docker container running FileBeat internally that you provide it. It's pre-configured to run with Logz.io. So it will have our shipping token, which is our way of identifying your account, etc. The listener that it needs to listen on, because we have clusters in many geographies, so we need to know which geography your cluster is in. And it's just connecting the container information from the host to the container itself so it can be streamed out. So if I run this, it will build, pull it, right, there we go. So we should now have the metrics collector running. And if I just run a few things, we should start seeing, there we go, all the different requests being made from that front page coming through, as is all the HTTP requests. See, they're easily identifiable as what type and where they're coming, which container they're coming from, the ID of the image, the ID of the container itself, all things that we can build more intelligent lookups on. What about the performance data? Well, get those as well. So we have a Docker container which grabs the performance information. It's one slide too far. So let's grab that and execute that. So that's going to be pulling the image from Docker Hub, and then building, executing. We're good. Just check. Says it's alive. Now, if we just a few executions and then reload, we have multi-line piece of information about performance, which we can then use later on to rebuild badly performing containers. Now, what about metrics? Well, we could configure metric beat. We could put this inside of the container itself, once again, or we could put it on the host and read off from there. But once again, we have the easy option, which is the metrics collector built by us. So we provide it on metrics token. Now, metrics inside of Logz.io are under a separate sub account of your primary account, just so that you can keep your logging information, your metric information separate, just to make life a little easier. So we'll grab that and we'll run that over here too. Go. Now we go to our logs account, go to metrics, which our metrics is built on Grafana. You can see that we are starting to receive some information. Now, if I change which dashboard we're running on and look at the Docker overview, you'll start seeing that we are receiving a number of containers running. So in this case, there is one of each of these containers running. Could obviously step this up and increase the number of WordPress instances looking in the database, number of containers. So this is really useful in, say, a auto-scaled environment where we want to know how many containers are running at any one time. Lovely pieces of information for actually making intelligent decisions. And it also includes things like memory allocation, etc. Like here we can see how much memory is being used at any one time between each of the metrics. You can also see the CPU allocation for the containers and the I/O and network. Now, what about if we wanted to know what was going on with the host itself? So we have this one which is looking at the information for the containers, but what about the host? Well, we have one for that as well. This is a container that will mount your host information to the container and allow that to be shipped over. Just to be completely transparent, that's not actually the advised route. The advised route is to use metric beat and configure it on the device locally to do it. However, this is Docker.com. We may as well use Docker for doing everything. So we'll build that. There we go. Now, if we go to here, we should start seeing a lot more information. So we're seeing the standard, but if we go to the infrastructure monitoring overall, we will then start seeing, hopefully in a moment, there we go, the additional of the actual system itself. So this will be returning the Linux kernel level metrics that we can use. So for example, if we have a container which has got Docker running with a bunch of auto-scaled containers on top doing, say, background tasks, but then it happens to have a read-only application of MySQL. So having it instead of the container, it's on the machine itself as a read-only replica. We wouldn't be able to see that MySQL is causing any issues with the Docker metric collector. So by allowing the systems metrics collector, we are then able to intelligently see where things on the system may be affecting how the application inside of the containers is running. Now, you will maybe be asking, where is the demo and the information on tracing? And I'm going to be honest, the best example I can possibly give you is going to the Jaeger examples and looking through the code for the odd example, as well as how it interacts with the agent, the collector, and the Jaeger UI. The reason for this is tracing is very much a application specific thing. So unlike with metrics or logs, where you can read them out from outside of your application and just consume those inside of Kibana or Grafana and have them hosted inside of Elasticsearch, these require you to go into your code base. Now, Jaeger has got libraries and does follow the open tracing standard, so you can implement it inside of your most of your languages of choice. But there's also the open telemetry program, which Jaeger is actively taking part in, which means it provides a simple set of APIs that allow for a common layer for logs, metrics, and traces from within your application to be sent out. OpenTelemetry has engaged with most languages to produce libraries, so you just have to use the library and provide it with the details of where your Jaeger collector is and where your metrics endpoints are, etc., and it will consume it and go from there. It's also been introduced into common frameworks. So Spring Boot has got an OpenTelemetry implementation plugin for it. This means from a framework perspective, you don't have to then put everything into your code base. You can include it in your overall framework and allow that to do the work for you. And where do we fit into all this as Logz.io? Well, we are an observability platform. We are built on the best of breed of open source. As you can see from my quick walkthrough, we are built on the ELK stack. So we are using Elasticsearch and Kibana for our logs. We are also using Grafana on top of Elasticsearch for our metrics. This means you have all of the brightest brains in open source and their knowledge, and we're just providing an operationalized access to it. You can also, we have blogs on this, connect up Jaeger to our Elasticsearch infrastructure, so you can store your traces with us and then use Kibana for visualization, or connect your Jaeger UI and run them from there as well. So we do allow for all perspectives of observability within our platform. We also, because of the fact we are running all of these, we have started to make small improvements to interconnect them. So we have made it so that you can drill down into the information. For example, a time span in your metrics can then be translated over to your logs, so you can directly see what information your application is producing around that, and then correct it where necessary. So if you have any questions, I'm around. You can also email me here at mike.elsmore@logz.io, or you can send me a tweet at ukmadels. Thanks very much.